Algebra 2 students. We're on lesson 79 in our textbook, so I'm going to be doing the problems from lesson 79. The topic is metric volume and 45, 45, 90 triangles. So remember, we've already talked about 30, 60, 90, so this is the 45, 45, 90 triangles. And then the metric volume should be pretty quick because we are pretty familiar with the metric. The only difference is now we might have to use centimeters cubed. So with example 1 in the textbook, it says use unit multipliers to convert 14,000 milliliters to liters. This is a pretty easy one. It's just your basic 14,000 milliliters. And we're just going to go straight to liters. So we have 1,000 milliliters in 1 liter. And so my answer then, we're just going to divide. And so 14 liters would be my final answer there. That's just your basic. Remember though that if it does say to use unit multipliers, that you actually show me your unit multiplier when you're doing the work. So then this next one is another one that talks about liters, but this one goes to cubic inches. So we're going to start out with 4.7 liters, and we're still using unit multipliers. So we know that 1 liter is equal to 1,000 centimeters cubed. And we know that we can go from centimeters to inches. There are 2.54 centimeters in 1 inch. So now we're in centimeters squared because we've canceled out one of the centimeters, but since there are 3, we need to do it 3 times. So we have 1 inch, 2.54 centimeters, 1 inch, 2.54 centimeters. Okay, so there's our 3 centimeters canceled out, and our liters was canceled out, and so now we've got 3 inches, so we're in cubic inches. And so my final answer, then I'm going to write it 4.7 times 1,000 over 2.54 cubed, and then I'm going to write my inches cubed. Okay, so that's all for the metric volume. It's pretty easy and just an extension of what we already know as far as that goes. So then we're moving to the 45, 45, 90 triangles. Remember we talked about on a 30, 60, 90, your side lengths. You can set up a similar triangle and use similar triangles when you're finding your x's and your y's. And so just a standard one would have a side length across from the 30 degrees of 1, across from the 90 degrees of 2, and then the proportion across from the 60 degrees is square root of 3. For a 45, 45, 90, we know that since these two angles are 45 degrees, these two side lengths would also be equal. And so we're going to set them as 1s, and then your hypotenuse then would be the square root of 2. So if we're going to use similar triangles to find x and y on this, our similar triangle would be our 1, 1, square root of 2, since this is a 45, 45, 90 triangle. And so then my scale factor would be this 7 over the square root of 2. So if my scale factor is 7 square root of 2, or 7 over the square root of 2, then I would multiply that by 1 to get the x and the y both. So if I multiply 7 over square root of 2 by 1, obviously then I still get 7 over the square root of 2. But remember, you do have to rationalize the denominators, so we're going to go ahead and multiply by square root of 2 and square root of 2. So x equals y equals 7 the square root of 2 over 2. And we can go ahead and write units since this is kind of a length. But that would be our final answer. So pretty basic, again, as far as that goes. We're just going to use our scale factor and similar triangles to do that. If you have any questions, message me in Schoology, and I'm going to post the problem set for you to do for your homework for tonight. Thanks, guys.